Hello and welcome to a brand new tutorial. Today we're in Houdini and we're going to look at creating a procedural domino system. We're going to start by creating some geometry. However, I'm just going to show you a couple of things with that. So I'm going to put a geometry node in. So you can get that geometry node by hitting tab on the keyboard and typing geo and then enter, and then you can click to place that down. I'm not a fan of how all of these parameters come into view up here, so I'm going to hide those by hitting this arrow button here. So if I click that, and then I can hit P on the keyboard and I get those parameters here instead, which is quite nice and handy. I also have a colour palette up here. You can get rid of that or show it by hitting C on the keyboard. So with that being said, we're going to dive into this geometry node. Cool. So to start this off, we need to create the domino. So I'm going to create a box, place that in there, and I'm going to change the scale, and I'm also going to make sure that the bottom of it comes to the origin instead of the middle of it. So for the size, I'm going to hit 0.2 on the X. On the Y, I'm going to go for 0.4. And then on the Z, we're going to go for 0.05. Cool. So then we get this domino shaped box, cube. And then the next thing we're going to do is I'm going to drag down from underneath the box that there's this output here. And I'm going to hit tab and search for a match size and view on that. Nothing happens when I view it immediately. Sometimes when you put a node in it, you will see an immediate change. However, I've not done anything with the node yet, so nothing's happened. So it's not updated. Another thing to note is that we have a few different boxes on each node. So this one here is our display node. So, our display option. The one below it, or this box here, is our template. So if I hit this template and then go to the match size and then make a change, so on our match size, we are going to change the justify Y to the minimum to bring that up to the origin here. I can still template the one before this node here, which is, you can see through here. If I turn that off on there, it goes. We also have bypass. So if we bypass that node, we've not got anything in there. And then we've got lock here. There is this information one which you can click there for, and it will bring this box up which you can move around, but as soon as you click off of it, it will go. Or you can hit this pin and you can click off of it and do other things, and you can still see all the information there. So on this box we have 8 points, 6 primitives, 24 vertices and 6 polygons. So and then you'll have to close that there as well. You can also get to that information box with one that will disappear on its own by just middle mouse button on the node, and you can see that information, but as soon as you let go of the middle mouse, it will disappear. Lovely. So we're going to start shaping this a bit more so that we can, it's a bit nicer shaped because it's very jagged. We have some pretty sharp edges. So I'm going to pull this down to here, and I'm going to go for a bevel. And we're going to change the distance on the bevel to 0.002 and then display that. If it was any bigger, or if we put it to 0.2, we get a different shape. We want to see the detail on there, so I'm going to get better shading on these edges here. Cool. And then the last thing that we want to do is we're going to put a UV unwrap onto here. All this is going to do is put some UVs onto this box that we've made, and we can view the UVs by having our mouse over the scene view and hitting space 5, and we can see the UVs there quite handily. And then I can hit space 1 to get back to the perspective view. 2 is our top view, 3 is our front view, and 4 is our right view. But we're going to stick to our perspective view for now. However, we have pretty much finished creating our domino for now. So I am going to create a null at the end of this. I'm going to view the null. I'm going to change the name to a domino out, or out domino, it's up to you. And then I'm just going to hit C on my keyboard to make that red, and then I'm going to make that disappear there. I will also put a network box in here around this so that these are all kept together. So now whenever I move that box, they all move together, and this is going to be my domino geometry. I can also colour that. I'm going to make it a green and make sure the colours are alright after that. Don't want this space too cluttered. Cool. So now that we've got our initial geometry, we now need to create a curve for it to go along. So what I'm going to do is I'm going to search in our network view for a curve spline, and I'm not going to connect it to anything just yet. I am going to view the curve, but I'm going to template that domino. In fact, I don't even need to do that. But I am going to hover over the scene view and hit space and 2 to get this top view. I'm just going to come in a little bit, probably something like that. Cool. So with this tool selected, I can hit enter in the viewport, and then I can start to plot points on this curve. If I want to snap to the grid, I can hold down X and I can snap to primitive, snap to point, multi-snap, or snap to grid. In this case, we're going to snap to the grid just for that first point there. And then I'm going to just get rid of that then by going back to it, by holding X and going back to the grid. And then I'm just going to start plotting points. I'm going to make a bit of a spiral, but I don't want these points to be too close to each other really. Cool, so something like that is fine. And then I can go back to our perspective view. Also going to hit escape so I'm not using that tool anymore. So now that we've got that, I'm going to grab this output from the domino out, and I'm going to type in a copy to points, and we need this one here, and that will automatically come in. I'm going to view that there, but we need to, so we've got the geometry going into it on this left side, but we now need the target points to copy to. So I'm going to copy that curve into there, and what you'll notice is these are all at those points that I plotted. So each one of those is at a single point. So what we need is we need to create more points on here. So we're going to resample on here and pop that in there. Then we've got loads of them. So we're actually, the reason we've got loads of them, and they're not quite intersecting, are they? Maybe. However, we could change that. So instead of using maximum segment length, we can use maximum segments. And now what you'll see is that they're on the curve. And I can turn this up and we get more of them. They're not too far away from each other either, so that's probably alright the way it is. However, we don't really, they're not really facing each other. So we've not really got anything happening. So if we can make them face each other by creating a tangent attribute, but we want the tangent to be on the normals, because the normals will be going to the next point. So if I view the normals on here, on the curve, and just the normals, let's not view that, let's just view that. And then we go to normals. Doesn't seem to want to show them now. Point trails, normals. However, okay, well that doesn't matter too much, but our normals are coming to the next point, so they're going to be going in it would start to look like a fairly hairy spiral, and it will always be going towards the next point. So on this resample, we can change this tangent U to our normals instead, and now when I go back to this copy to points, they'll be facing the next point, right the way around. Lovely. Cool, so now with that in place, in fact, we could do this, the good thing about Houdini and why this is so interesting and why I get so excited by it is how easy it is to make things procedural. So if I put a switch node in here and then add a circle on this second input, I can then, so if I was to, let me template the circle, so we see it there. We need it to be on the grid, so we'll put it on the ZX plane. We can turn the divisions right up, and then we can put the uniform scale up. Cool. So with that in place there, and if I switch to it on here, we can now use this shape for our points, and the dominoes will go round that instead. The same could be said for any other curves that you might make. So once you've created this tool, and say you have something similar that you want to create, you can do it quite easily and quite procedurally here. Another thing we could do is we can, let's just bring all of these down a bit. Put a transform in here. And let's switch back to our first input. With this transform, I can then make that bigger so that they're further away. What I would have to do then is I'd need to resample it and start putting that up much higher so that they would actually hit each other. So that's something to bear in mind there as well. But we won't use that. And look, there's me using the bypass there, so I don't need to, but I'm going to on this occasion. I could have just deleted that. Cool, so we've got that in place there, which is really handy for us. So we can start to create a simple rigid body dynamic system. So I'm going to grab the copy to points and type in rbd configure. I'm going to bring that node in. So I'm just going to bring that down a bit further so we can have a look into this a little bit more. So we have a few different groups in here, and what you might notice is we have physical attributes, and it has some real world values here. So if we wanted the value of steel, we have all the density, the kilograms per meter squared, the bounce, the friction, all of that already set in this. However, our dominoes we don't want to be steel. We're going to leave them as concrete and keep them at the default. I mean, we could try things like this a little bit later. In fact, I think there is a marble texture that we can use with this a little bit later, but we'll ignore that for now and we'll concentrate on this. Cool. So the next thing that we need is a RBD bullet solver. We could just plug that in underneath here. However, you'll notice that this has 3 outputs. So we need to put 3 outputs in, at least. All 3 outputs. So we've got our geometry, then we've got our constraint geometry, and then our proxy geometry. So that we've got all of that in there. That's going to work quite nicely. So what I'm going to do now is I need to create a ball to knock this all over, or a sphere to knock it all over. So I'm going to come in a bit closer so we can see everything a bit more readily. I'm going to create a sphere here. I'm going to set it to polygon, and I'm going to view that, but I'm going to template the RBD solver so that I can always see where my first domino is. I'm going to turn the uniform scale to 0.4, and then I'm going to translate this, or transform this, so that we can pick a good position for it. So what you'll notice is in the bottom corner here, down here, but when I move my mouse into the network view, we see our which way each parameter goes. So Z is going this way along this. So when we move our ball on this here, don't need to go too far, but we can just bring it to around there. We can also just bring it a bit higher so it's not within the grid, and we can get it rolling as well. Something I do want to do is just put the frequency up as well, so we've got a nice round ball instead of a weirdly shaped ball. Cool. So we're going to add an RBD configure here as well, because we want this shape, this geometry to move as well. However, we are going to change the type that this is. So the type of this ball is going to be metal, and we're going to make it into, let's make it into gold, because there's a nice gold texture that can go with. And it's quite dense material. Cool. So what I can do now is I'm gonna take this off for now. Yeah. And I'm going to pack these up, because we want to merge them together, but we have 3 inputs, and 3 inputs won't go into one merge. So we need to make sure that we pack all of these to then unpack them after. So I'm going to go to RBD pack and pull each of these in here. Then I'm going to pull the same thing out of it. So to pull this out of, or to duplicate a node, you can hold Alt on it and pull it away from it, and you get a second one that's exactly the same, with all the same settings and everything. So then I've got, and you'll notice that I've got one output from each of these now, so I can put them into a merge node quite easily. So I'll drop that in there and pull that into there. But now I've only got one, right? And I need to put in at least those first 3. So I'm going to go to RBD unpack and pull them all back in, and we can view that now. And we've got all of those back in and all working together there. So now that I've got all that set up, they all just fall to the ground. Well, there is no ground yet. We can set a ground up in this RBD bullet solver. So I'm going to go to collision, the collision tab up here, and I'm going to go to ground type and ground plane. Now they'll all just land on there, but they all wiggle for a little while before, and they've got quite an intense wiggle. This one doesn't react very well either, so if they go under the ground. The reason for that is because the ball and this this first domino they all have the same name. So if we go to our geometry spreadsheet, we have a name value, and we've got all of these different pieces that make up what we've got. So if we look at all of these, there's nothing to specify what's what in here. I don't know why I've got that. Why is that 51 there? Okay, so this piece 0 must be the ball, right? So if I look at piece 51, is that going to highlight it for me? No. What I can do is, in fact, I'll put a group in here, and we'll go for piece 51. We'll highlight that, and that looks like it's the ball to me. So if I delete that node, go back to that, yeah, that was the ball. So we need to change the name of this sphere. And we can do that by getting a name node and popping that in here. And we're just going to call this ball. Another thing to note is that it's not moving in the right direction. So with that name node in there, it should now just drop, and they've got a bit of a wiggle, which is fine. We can deal with that wiggle on this solver here, and we can go to this collision padding, and we're going to put 0.001 in there, and that will minimize it. It won't stop it completely, but it should minimize it. Turn that friction up. That doesn't do anything anyway. Cool. Try turning up these substeps a bit as well. Might be a bit slower, but we get a bit more around here. We don't get that same wiggle. Still wiggling a little bit, but not quite as much. Much more accurate to what we need. And if I turn that back to one substep, get much more wiggle. Turn that substep. Let's go for 5. Might not get any wiggle. Reasonably happy with that. Cool. Yeah. So now what we need is we need this ball to hit into this domino to start the chain reaction going off. To do that, we're going to need a node called point velocity. And we can chuck that in just under that name node that we've just made. And on this point velocity, all we need to do is add velocity to one of the axes. So remember I said we were on the z-axis down here, and it looks to me like we need to move in the negative direction as well. So this is -1 here, and we have 1 here. So I'm going to go x, y, z. I'm going to put -1 into there, see how much it moves. And then that's going to start the chain reaction off from there. It should go right the way around. If we had a bit longer time on here, it would go all the way around, but I've only got 10 seconds. And if we were to watch it in real time, we'll just see the same thing, just over 10 seconds instead of it all going through. You can change how long this is by changing it in here. So if I put this up to 480, we then have 20 seconds. It's a bit of a long way to watch this go right the way through though. So we don't necessarily need to worry about that too much, but we'll probably see the majority of these dominoes fall over 20 seconds. I was also testing how long I could make up what I'm saying on the spot while this runs right the way through. Doesn't look like we'll even get to right the way through with, are we? Oh, we hit it, but it didn't quite fall over. Awesome. So we've got all of this set up now. So we can look at caching this simulation out. So I'm just going to organize this a bit better. Just pull these out. Pull this out here a bit more. That can go level with that. That could be in line with that. And then these can all move in a little bit more. Like this. There we go. So I'm going to select all of these, and I'm going to put another network box, and I'm going to call this simulation. And again, I'm going to color it. So if I bring the colors up, select that, I'm just going to set it to blue. Then put the colors away. So now that I've got that, you can cache the simulation out so you don't need to wait for it to update each time by adding a node called a RBDIO. So this will differ depending on what you're doing, what you want. If you were doing pyro, you would cache it out a very different way to how we'd cache this out. And the same goes for fluids. And it's got 4 inputs and 4 outputs. So it can go back into other things as well. So what you can do is you can view it on there, and you can see all of this here happening in the simulation. You could save it to disk, you could change the frame range. If you were to change the amount of frames you've got throughout the whole simulation, this will change automatically. That's why it's in green. Just be sure to name what it is you're trying to do in there. So we're just going to have a look at making this a bit nicer looking. So I'm going to add a couple of material nodes. So if I grab this name here, I'm going to put the material node in there. Then I'm going to Alt and drag that out. To cut those, if you hold Y and drag across it, you can pull it out. I'm going to pop that into this copy to points. I'm going to find a couple of materials that we could use. So I set the ball to gold, so we'll make that gold. And all of these are a default type of concrete, so it doesn't really matter what we create here, but we can specify here. Do we want concrete, or shall we go for something a bit? We could go for a clay. Yeah, we'll go for a clay. And we're going to bring bricks in as well. So there's a brick material in there as well, which we're going to use. So to make this all look a little bit nicer, I'm going to create a grid. I'm going to chuck that in here. I'm going to dive in. So everything fits onto the grid there. So in fact, let's go back to that geometry here. Just want to make sure that we can see these materials on here. Okay, we'll figure that out in a little bit. So on this grid, I'm just going to create a transform to make the Z bigger and display the Z. That's fine. I'm also going to make the rows and columns 50 by 50. That way we should get a bit of a nicer material on it. Going to go for we can extrude. So we'll extrude there. We'll go to 1, for example. Let's go. Look at that. It covers everything there then. Let's bevel it as well. Just put that up to 0.1. 0.01. Nicer. Then we can UV unwrap. And then we can match size and bring that to the right place. So there's everything underneath it. Well, it's underneath everything in there. On this grid, sorry, this poly extrude, just going to make that 0.5 instead. Oh, that's 0.5. There we go. Cool. Then I could put a material on here. View that, and I'm going to add those bricks in there. I don't think I did that, did I? No, I didn't add the gold. So this is the clay on the dominoes. Hopefully that will update. And then on here we've got the gold, and we're setting the material on there. So if we view that there, we see that gold. Cool. So now I'm going to set up a light in here, and I'm just going to click environment light up here, so we've got it in there and it's looking directly at everything. We can that's fine. We can set an environment map here, so it will bring you to this folder in here, if you click on this, on the environment light, what you can do, you can go to Houdini pick HDRI, and I'm just going to go to this garage one. The other ones are outside, and they're quite nice, but this is the default lighting that I'm going to set for us here. Is that poly extrude? Not. Put a fill in. And we'll fill with single polygon. Cool. So that's just filling in the bottom there. That is cool. So we've got all of our materials set. We've got a light in here, so we want a camera really. So I'm just going to come in and place a camera, maybe a little bit something like this. And when I've got the perspective camera positioned how I want, I can control and click on this camera up here, which will set the camera position here. So once I've done that, I can get rid of, I can move around it and change the positioning of the camera, or I can unlock this and then I can move my way out of the camera, and we can see that camera has stayed where it is in the scene. So I'm just going to go to our out network, and I'm going to put a mantra node in here. This mantra node should, once we've changed a few things, so we can change with override camera resolution and use a specific user specified 1920 by 1080, what would be what I would render in, and then you can see where you would output it to. If I bring this out a bit further, here you can create it as a EXR, a TIFF, a PNG, JPEG, whatever you think would be, whatever you need for whatever it is you're doing. Cool. So you can specify all of that here. All you would need to do is get rid of that bit and just name it as you, so let's say domino underscore sim, and then you can render through that camera there. It's because it's using that correct camera there. Render current frame or render frame range. Again, you can delete that channel and set that to 10 seconds if you wanted. We've got a simulation of 20 seconds, which is fine. And then I'm just going to go back to our objects here. We can have a look at that render view. So we're going to use cam1, use the out mantra, and we're going to render. So it'll take a moment. Should have gone somewhere further in the simulation really, when we can see it all falling over. There should be Dominos. I'm gonna need to scroll out a bit, I think. Taking a moment. Oh, so at the minute it's not quite using the correct materials on here. So if I just view that, should get an update and it should start to figure out how we want the dominoes to look. Give it a moment. We can also edit how the material works as well. I'm going to do the same for the gold. Get the ball in and then go back to the RBD IO and we get all of that. I'm going to move forward about 3 seconds. And we'll see how the simulation looks and how it updates in the render view. So at the moment down here it's just telling me where it's up to, and then in the render view we'll see what point the simulation is out at this point. It will take a little while to render using this renderer, however I'm not too fussed on that at this point. It's more to get you guys used to using Houdini